All right, today we're going to dive into the hidden communication that's humming along behind the scenes, powering our entire modern world. It's a story about two different languages, one that starts right at the side of your house and another that's spoken in the heart of the grid to keep your lights on.
So what language does your smart meter speak? It seems like a simple enough question, doesn't it? But packed inside that little box is this incredibly complex world of communication. I mean, it obviously has to talk to the utility company for billing, but what about the rest of the grid? Well, it turns out the grid isn't just speaking one language. It's actually bilingual, speaking two totally different languages for two totally different jobs.
And these are the two heavy hitters, DLMS/CASM and IEC 1685. Think of DLMS/CASM as the meticulous accountant, carefully designed for billing and collecting data from your meter. But IEC 1685, that's the high-speed, high-stakes language of grid control, where preventing a catastrophic blackout is literally measured in milliseconds. Let's break them both down.
Okay, so let's start at home base, the smart meter. This device needs a totally standardized way to report exactly what it's measuring, and that's precisely where DLMS/COSEM comes into play.
So, first up, you've got COSEM. The easiest way to think about this is as a universal dictionary or vocabulary. It gives a standard name and a standard structure to every single piece of data inside any smart meter. Doesn't matter who made it, your total energy use, the current voltage. COSEM basically slaps a universal label on it so everyone knows what they're looking at. And then you've got DLMS. Now, if COSEM is the vocabulary, the list of words, then DLMS is the grammar. It's the set of rules, the commands, the actual protocol that lets the utility communicate with all those COSEM objects. It defines exactly how to ask the meter a question and how that meter is supposed to answer back. And the way COSEM structures all this is actually pretty smart. It starts with something called an interface class. Just think of it as a blueprint or, a PowerPoint template. From that template, you create a specific object, which is like your actual presentation. And that object holds all the good stuff, the attributes, which is the data itself, and the methods, which are the actions it can perform. So you've got potentially thousands of data points in a single meter. How on earth does the system find the exact one it needs? Well, it uses this, an OBIS code. It's like a hyper-specific postal code, but for data. Just look at this example. Each part of the code tells you something. The first byte says we're talking about electricity. The next few narrow it down to active energy, total. And that very last byte, that tells you it's the current value, not last month's. It is an incredibly precise system. There's no room for error. So, you've got all this crazy complexity, right? All these objects and codes, but it all boils down to just three simple commands. You can get data, read your energy usage. You can set data, maybe to update a pricing plan, or you can tell it to perform an action, and this is a big one, like remotely connecting or disconnecting the power. Simple, powerful, and totally standardized. All right, buckle up. We're leaving your meter behind and heading up the wire into the absolute nerve center of the power grid, the substation. Now, in here, the priorities are completely different. Nobody cares about billing data. What matters is speed, rock-solid reliability, and instant control. And for that, you need a whole new language. See, IEC 61850 thinks about the world completely differently. It's all about the job that needs to be done. The basic building block here is called a logical node. You can just think of it like a dedicated app for a specific function, like XCBR, which is the app for controlling a circuit breaker. Inside that app, you have data objects holding key info, like pause for its position. And finally, you have data attributes with the actual value, like telling you if it's open or closed right now. It's a structure that's built for action. So how does this incredibly complex web of high-tech devices all know how to talk to each other? It's all orchestrated by a master blueprint called SCL, the Substation Configuration Language. This one file is the master script for the entire show. It tells every single device its job, what data it needs to look for, and exactly which other devices it needs to talk to and when.
Now, this is where things get really cool. Unlike DLMS with its simple little get, set, action toolkit, IEC 16850 knows that not all communication is created equal. It uses a whole team of 3 specialized protocols, and each one is optimized for a very specific task. First, you've got MMS. That's for your day-to-day chats, routine data collection, non-urgent commands, that sort of thing. But for emergencies, you bring in the special forces, Goose and sampled values.
These protocols are built for one thing and one thing only: pure speed. They actually bypass all the normal network traffic to send critical trip signals or stream raw voltage data directly. We're talking a few milliseconds here, fast enough to stop a cascading failure before it even starts.
So there we have it. Two incredibly sophisticated yet wildly different standards. Now that we've met both players, let's put them in the ring, side by side, to really see what makes them tick and why the grid absolutely needs both.
And this chart just lays it all out, doesn't it? DLMS/COSEM is all about objects, using those super specific OBIS codes to pull billing and monitoring data from the edge of the grid. But IEC 6185E is all about function, built for extreme speed and reliability to operate the very core of the grid. You could say one is about looking back at what was used, the other is about controlling what happens right now.
You know, when you boil it all down, it's really this simple. One language is for accounting, and the other is for action. DLMS handles the business side of things, making sure the energy consumption numbers are right, and IEC 61850 handles the raw physics of energy delivery, making absolutely sure the lights stay on for everyone. And that leaves us with a really fascinating question for the future. For decades, right, these two languages have lived in completely separate worlds, with a clear line between them. But now, with rooftop solar, EV chargers, home batteries, our homes are becoming active players in the grid. That line is getting blurrier by the day. The language of billing and the language of control might need to start having a much more direct conversation, and soon. The big question is, how are they going to do it?